Okay, so this is the cast diagram. So this cast is an abbreviation. It stands for, the C stands for cos, the A stands for oil, S stands for sine, T stands for tangent, tan. So you have your Cartesian plane, and then what makes it a cast diagram is that it's the abbreviation. So you say C A S T, cast. So what this means is that, okay, first I will name the quadrants so that you understand. So this is quadrant number 1, 2, 3, 4. So this 1, 2, 3, 4, it means the angles are moving this way. Okay, I don't know if that's important, but maybe it will help you memorize that the quadrants are like this. So if it's this is 1, 2, 3, 4. You never count like this. This is always 1, 2, 3, 4. Okay. So the A means oil. Basically, we are talking about which trig ratio belongs where. Not really belongs, but where is it positive and where is it negative. So oil means all the trig ratios are positive in the first quadrant, meaning cos, sine, tan are all positive here. So if you happen to say cos of whatever number, add tan of whatever number, and it gives you a negative angle, whether it's whatever angle you can think of, negative 45 degrees, it means it does not fall under the first quadrant. And then we go to the second quadrant where only sine is positive. So it means if you are saying sine of whatever angle, and let's say you get 30 degrees, if that 30 degrees is positive, it means your angle is in here. But if it's you say sine of whatever and your answer is negative, it is not here. It is wherever sine is not positive. I don't know if it makes sense. Okay, so only sine is positive. And then on the third quadrant, it's 10, meaning this is the only quadrant. Okay, not the only, because it's also positive here. This is the quadrant where tan is positive. And then here, this is the quadrant where cos is positive. So you see these three. When I say sine is positive, only sine is positive here, it means all the other angles are negative. Also here, because I said tan is positive, it means all the other ones are negative. When I say the other ones, I'm talking about the ratios that are not written here. It's sine and cos. They are negative in this quadrant. And then here, it's cos, meaning cos is positive here, and all the other ones, tan and sine, are negative here. So what it means is that if you have cos of whatever angle, cos of whatever angle, and it gives you maybe positive 30 degrees, then you know that the angle is here. But if it gives you something like negative 30 degrees, it's not here. It will either be here or here, because here all of them are positive. So it will either be here, and you will, how you choose where it falls is with they'll give you, what is it called? Something like a domain. Maybe they can say -180 or so. A restriction. A restriction can tell you where the angle falls if you have to choose between. Sometimes it's both. You can have two solutions. you can also have one solution. If you are given a restriction to say your angle is negative, let's say they say cos is negative, but it's between 0 and 180. So you will know, okay, I will explain the 180, the angles later. But then if they tell you the angle is between this and this, you will say, okay, it means the restriction puts us here, we cannot go here, so the cos will fall under here. Okay, now I'm going to add the angles. So you see this, two straight lines cross each other. Obviously, we'll have a corner here in the middle. In this corner, it means 90 degrees. Yeah. So meaning your reference angle that you use, this angle that you got when you said cos of this, or you said theta is equal to cos of whatever, and then you got 30 degrees. It means this 30 degrees, if you put it here, its relationship with the first, if it's found in the first quadrant, its relationship with this, the total angle, is 90 degrees minus theta. Because it's less than, if it's in the first quadrant, it's either less than 90 or equal to 90 degrees. You see, this line, at this line, there's no angle between whatever line that you may draw on top and the x-axis. There is no angle, so it's flat, it's 0. Once you move like this, then you start getting your angles. You get your 30, 60, 70, 80, whatever, 85, until 90 degrees. So the limit for this is 90 degrees, meaning whatever angles that falls in here is either 90 degrees or less. So to get the actual angle after calculating this, you say 90 degrees minus the reference, which is, the reference is this thing that you calculate here. I don't know if it makes sense. And then we go to the second quadrant. Because you see this, whatever angle, because I said your angles go like this, it means this is not 0. You don't say this is, okay, this is 90 degrees. But the total of the angle that you find here is not 90, because you start here, it doesn't just start here and then go like this. It starts here. You go this way, we already have 90. We say plus whatever that is in here. But the maximum size of the angle that you can find in the second quadrant is 180. How did they get 180? They said this 90 and this 90. So in total, whatever angle that falls, you see this one, whatever angles that go like this, the maximum is 180. So this angle cannot be more than 180. It's either 180 or less. So you will say 180 minus theta. Meaning this theta is still your reference angle that you calculated. This, let's say if you said cos or whatever, this is the reference angle, and you use it on these quadrants to see what the actual angle is. So the condition, this is what gives us these are the conditions. So the condition in the second quadrant is 180 minus theta, simply because the angle that you find here has to be 180 or less, you see. And then we come to the third quadrant. This is another 90. 90, 90, 90. This will give you 90 plus 90 plus 90. It can give you, okay, it will give you 270 degrees minus theta. Ish, my pencil. You see, the maximum from here, to here, the maximum angle, the maximum size of the angle is 270. Meaning, why am I saying 0 degrees? Meaning the angle that is in this quadrant, it has to be 270 or less. And it can also mean that since this one, the maximum was 180, once you go above 180, it's 180 plus. 180 plus what? Always the reference angle, you see. And as we don't use 270, our syllabus does not, this is not used in our syllabus, but it is also a condition that can be used for this quadrant. So we just stick to 180 plus. And then remember, theta is your reference angle that you calculate when you say cos of a number is equal to positive 30 degrees, positive 60, or 90, whatever. That angle is a reference angle. To find the actual angle, you have to come here. Yeah. 80 plus, okay. And then, so this is the only quadrant. Quadrant 3 is the only quadrant with the exception. You see? It's the only quadrant with this exception. We just don't use 270. We only use 180 plus. But if you want here, it's okay. It's 90 minus. And if you want here, you can say it's 90 plus because it's more than 90. You see? You can also say 90 plus. But it's really unnecessary. This is not the main one that we use. The main condition here is this one. And then here it's this one. And then in the fourth quadrant, our condition, okay, this is another 90 degrees. This is like a revolution now. Do you see? It's a circle. All these angles around a point, they add up to 360 degrees. So angles that are, you see, you go like this, you go like this, you go back. It's a 360, it's a revolution. We see from here to this line, it's a circle. So meaning the angle that is here is 360 minus theta. That is the condition in the fourth quadrant. Because the maximum that you can get in the fourth quadrant is 360 degrees. So the angle that is in here is either 360 or less. So that's why we say 360 minus. And if we were using 270, because the maximum is 270. Once we go over, now the angle is increasing from 270, we can then say 270 plus theta, you see. But we don't use 270. We stick to 360 degrees. So here is 360 minus. Now I'm going to convert to radians. You see, this 360, if we convert it to radians by saying times pi over 180 degrees, we get 2 pi. You see, this whole thing, 360 in radians is 2 pi. And then we just say minus theta. You see, that is the condition in radians. It's 2 pi minus theta. And then here we have 90 minus, this 90 we convert it to radians by saying pi over 180. We multiply by pi over 180 degrees. And then we get, this must be pi over 2. It's half of 180 minus theta. You see, it's pi over 2. That is the condition in radians. This is 90 minus theta is the condition in degrees. Pi over 2 minus theta is the condition in radians. We come back to this 180 minus theta. It's pi over 180 times 180 degrees minus theta. So we are converting the angle to radians. So this cancels this and we are left with pi minus theta. That is the condition here. And then here it's 180 degrees plus, you see 180 is pi, so we can just say pi plus theta. Those are the conditions in each of the quadrants. In quadrant 1, it's 90 minus theta, or pi over 2 minus theta, which is in radians. And then here in degrees, it's 180 minus theta. In radians, we say pi minus theta. Here it's 180 degrees plus theta. In radians, it's pi plus theta. Here it's 360 degrees minus theta. In radians, it's 2 pi minus theta. And then, if you understand this, in the next example, I'm going to show you how you actually use everything. Why do we have all these things? What do we use them for? That's what I'm going to explain in the next video.